Welcome on this new course on how to create value from data. So maybe I should start by saying that this presentation does not ambition to give recipes that mechanically would lead from data to value, right? It's not something that can be described in a precise and detailed and mechanistic manner. This said, very often we meet managers in companies who know that there is this big thing about data nowadays and that there is value in data. Data is the new oil. And there is no where to look at that would give a start as to what are the directions that I should take in order to start thinking about how to extract value or get some value from my data. And this presentation is a kind of primer or kickstart in the thinking or brainstorming about how can you go from data that sits in your companies to a value proposition. And I think that there are essential building blocks that can be mixed and used together, and that we meet very often in a lot of data-driven business proposals. And these are these essential building blocks that I'm going to describe now, not pretending that this is a full list, but I think it's still very helpful to keep them in mind when we think of value creation from data. So let's take them one per one. The first one is the first direction that we could think of is prediction. Data is a very good material if you want to build a value proposal based on prediction. Basically, to exemplify what I mean immediately, data can help you predicting a credit score, or it can help you predict crime in some instances. It can help you predict the success of a commercial offer that you make. It can help you predict which customer would leave you soon, and for what reason. So prediction is a very large family of products that can be built on data. What you need to do that is you need historical data, basically. So if you want to predict something in the future, you need to base your predictions on a collection of data that you gathered in the past. So that's something you need, of course. This data has to be specific to your domain. That seems obvious, right? If you want to predict sales, you should have data on sales. But sometimes things are not that obvious, and that's why I remind it here. You might need data mashups in the sense that one data set might not be enough to predict accurately something happening in the future, and you should always keep in mind that aggregating and integrating different data sets that can actually interface one with each other can lead to a better accuracy of your prediction model. And finally, but that's really not the least important, you need a feedback mechanism that will collect information about whether the predictions that your product made, whether the prediction was correct or not. Because this information about the result you can feed you can feed it back into the system to correct the algorithms that you use and to make them adjust their next prediction. And this is how a system based on prediction improves day after day. And this feedback mechanism is something you have to build, and you have to basically put a lot of thinking into. The hard part in this, if you use prediction, is that it's hard to start. Sometimes you have not a lot of historical data, so your predictions do not have a lot of ingredients to build on, and you don't have any feedback yet on the accuracy of your predictions. So the first predictions might not be completely on target. You might miss what is called the long tail, which is that your predictions at the beginning might completely focus on average behavior or average patterns. And this means that your prediction engine could miss all the singularities, all the outliers that actually happen in real life, the black swans. So that's a risk that can't be completely mitigated when you do prediction. And finally, a very hard part as well is over-reliance. It's not because you have a prediction with an 80% confidence score that what is predicted is going to arrive, right? You always have to think that it's all about probabilities, and you should never leave human judgment outside of the loop. Okay, so prediction is a very common building block in data-driven business models. The next one, so prediction is quite, common and famous. I suppose we are not surprised by this one. I personally prefer this one in terms of richness of the value which is created. Suggestion mechanisms or recommendation systems. This is a way to work with data that results not in a prediction but in suggestions. You basically offer a choice to, whoever is interested in your analysis. So it's not constrained. The result of a suggestion mechanism is not, you should do that or this will happen. It's like, according to our data, these are the 3 best choices you could make. And please choose among them. The data will not tell you which choice is better. This is for you to decide. So examples of suggestion mechanisms are, when you type a search on Google, you see a suggestion that other users actually made related searches, right? So it doesn't tell you that you should try these other ones. It offers you a range of options for you to choose from if you want. Same for Amazon's product recommendation system. Amazon doesn't push you for one book if you looked for another. It just tells you in a very free manner that other customers who viewed this book also viewed the others. So no prediction about your satisfaction if you buy this book instead of the other. It's more an information about your options. And finally, in the retail world, recommendation systems tell you which other products would fit your profile, but again, in a very open-ended manner. So to do that, a bit just like for prediction, you would need a rich data set coming from past transactions or past historical data, and you need a feedback mechanism that will tell you, the analyst, which of the recommended products were actually chosen by the customer that you suggested these offers. What I mentioned on the slide, the serendipity problem, is the following. And the issue you can have with the suggestion system is that all suggestions will be tightly related to past behavior. So these suggestions might never deviate from past experience. So suggestions might never actually include new things, or things that are a bit unusual and innovative and different. So it's very hard, but it's actually that's what suggestion systems should do. They should, of course, base their recommendations on past history, but they should also include a measure of serendipity, which is this degree of randomness and newness, which make the best suggestions, in my opinion. The next thing that you can use to create value from your data is curation. So by curation, I mean the fact that you clean up, you standardize, you deduplicate, you curate data. So maybe you were given through whatever channel, maybe your customer's loyalty program, or through any other data set that you got interesting data, but completely crap, in the sense that it was full of missing values, full of incorrect values, not standardized in a proper way. The value that you can get from that is if you put the effort, if you invest in the cleaning of this data, if you make it clean, correcting the errors, filling in the missing values, if you standardize the formats so that the dirty data set that you had becomes one that can be exploited in a snap, this is value, this is a data set that you can then sell to customers. So that's the core of the business of Thomson Reuters. That's also the core of the business of Nielsen and IRI, or IRI, which basically collect hard-to-find data in stores, which is messy, and they really take the pain to clean it and standardize it and aggregate it and classify it, and they can sell it at a very high value to product makers and stores that are interested in how they manage. The difficulties in this way to create value is that, the first one I would identify is that you have to find the proper workforce to conduct that, to conduct this work, because since it can be very that's a work that can be very manual. Sometimes you should have somebody to manually check entries in your data set. That can involve a lot of manual labor. So what about costs? You have a very difficult search to make between cheap labor, because you can't afford to have PhDs checking your the entries of your data sets, but you don't want unskilled labor that would just not perform the corrections as you need, and that would just make misinformed choices in the cleaning of the data. So options that you have is to use, for example, Mechanical Turk, which is a service provided by Amazon, and I let you check what it is. Or you have to basically find the right incentives to motivate your workforce, so that basically you can manage the costs and the quality. The next possibility to create value from data is to enrich data. So it's very much related to data integration. It's a process that consists in having a look for which data sets, if combined and when combined, would actually be worth more than their parts. So if you you have to have skills in data mashups, you have to have colleagues who and staff who know about APIs and where to find publicly available data sets and private data sets, and if so, at which cost. So you have to have this staff which is aware of the difficulties and opportunities of aggregating and mixing different data sets. And the result is that you can create from these different data sets that each of them is not of great value, you can create with something which is basically uniquely informative to some of your customers. So it would allow you to sell barometers or dashboards or basically or benchmarks, any kind of data which you had to create yourself by combining different data sets, and which is of very much interest to customers because they couldn't create it themselves. The difficulties there is that you should, given the effort involved, you should have a clear view on what are the market expectations in terms of rich data sets. You should make sure that your efforts are hard to replicate, because if your data mashup is too easy to replicate, well, you will have copycats anytime soon. And you should also establish the legitimacy of your product, because if you are basically selling on the market the best dashboard on, I don't know, your performance on Twitter with new metrics that you build from different data sets, these metrics, people should trust them, because you will not share the whole process on how you constructed them. That's kind of your industrial secret. But if you don't share how these metrics are created, people should trust them. So you should have enough legitimacy to have these rich data sets or rich indicators to sell. The next one is the next building block or element you can play with to create value from your data is ranking or matching or comparing. If you have data in your that you own, you can provide a service where this data will be ranked, or you will do matching, or you will do comparisons that are judged of a value by your customers. So of course, all the online dating sites are based on this utilization of data. Their core product is the matching of profiles the best way possible, depending on the data which is present in the profiles of their users. But search engines, if you take Google, their core model is to find a way to analyze data so that the results of your query are classified, are ranked in a way that makes the best sense to you. So here again, getting a feedback mechanism is key. You want to know to what extent the ranking or the matching or the comparison that you suggested to the user did make sense, and if not, you want to record this correction to improve your ranking system or matching system. And that's it. This is, of course, a very popular brick in any business model. And the last two bricks I'd like to discuss are segmentation. you can segment data sets and classification. These are kind of close but a bit different. So segmentation is the process of organizing a huge data set that doesn't make sense because it's so heterogeneous and so big into subgroups. And if you're in the marketing and research industry, if you're in product development, or if you're in advertising, this process of segmentation is very, very important. Again, because you need to target specific customers, and if you have a crowd of customers, the first step is segmenting this crowd into subgroups you can target. So the segmentation that you apply to a data set is essential. The difficulties in segmentation are numerous. The first one would be that the key step in segmentation is that you should find to what extent each of the entities in your group that you want to segment, how are these entities relating to each other? And this is for nobody else to decide than you. So the relations between the entities are for you to decide, and that's a tricky step where you can do missteps. You also have the difficulty that when you arrive at a segmentation, it's up to you to decide whether it's satisfying or not. Is it a segmentation that I'm happy with, or is it actually something I can't trust? That's something that will not be decided for you. You have to take responsibility for that. You have to be able to deal with boundary cases where one customer or one product or one entity doesn't fit neatly in one segment or the other. What do you do with these particular entities? That's again something to think about. And something else I'd like to mention, the decision very early in segmentation, which is, do I go for disjoint segments that can't overlap, or do I find it interesting to segment my group into overlapping segments, meaning that one entity can belong to one group and to another? That has huge consequences practically down the line, and that's something that, well, you should decide early on. And classification is basically close to segmentation, but the difference is that you have a data set and you want to classify new data entries into one group or another, or into different groups. So segmentation is about cutting an existing group into chunks, into segments. Classification is about, I have a new data point coming in which group should I classify it? So it's a very active process. This is at the basis of many applications such as spam detection, algorithmic trading, or medical applications. If you want to basically, you have a new patient coming in, and based on your past data of past patients and their symptoms, this new patient, can you quickly and accurately decide what is its pathology based on the symptoms? So this classification act is the value that is extracted from the data. The hard part in this way to deal with data is to evaluate the quality of your classification. Then it's to again evaluate boundary cases where you have a high uncertainty as to the result of the classification. And finally, it's also a matter for you to decide whether you leave the classification to be completely unsupervised, or whether you have an active role in it. Last, just a quick look into the fact that, of course, this is not an either-or process. It's not that you will create value from the data by choosing curation or segmentation or ranking. It's very often, it's always actually a matter of mixing all of these approaches in a way that maximizes the value you can get from the data for your customers. And here there is no basic recipe. I just give a couple of simplified examples of how some business models can be described as a combination of these building bricks. But that's very much for an entrepreneur to think hard and come up with their own combinations. That's it, and thank you.